Hello, today we are going to take a look at question 687, longest univalue path. In this problem, we are given a binary tree. Our job is to find the length of the longest path, where each node in the path has the same value. Now, let me explain. In example 1, let's first take a look at the node. Node says the length of paths between two nodes is represented by the number of edges between them. So the length is represented by the number of edges between them, for example, and it has to have the same value. So here you can see this is the longest path, and there are two edges between them. That is why we return 2. And in example 2, we find the longest path is this. And there are two edges between them. That is why we return 2 as well. So there's a precondition, which is this path may or may not pass through the root. That is why the example 2 works. Sorry for I think I explained this question quite badly, but I guess you get roughly what I mean. Now I will get into coding. First, let's take care of the exception. And first, let's think about the nature of this problem. So you can see because this kind of path problem, it can always be solved by a way which is using recursive method. Because it is its nature that those kind of problem you have to go through nodes, and in the node you have to go through all the node. That is why we can decide to use recursive method. And second, this problem has we have already seen two patterns in the example. One is this, one is this. So we can say it contains the recursion of left side and right side. So we must combine them together. And the third part is this problem is a problem to get extreme value. In this case, we need to get the longest univalue path. The longest, which means we need to get the maximum of the path length. Now we get these 3 points in check. Now let's get into coding. First, because we need the maximum number, and in these problems we always create a variable to store the current maximum number. The variable in this case is the value we have to return. It's the current maximum path length. And then we have to define our recursive function, which we call it longest path at, and we give it 2 signatures. The first one is node, the second one is value. So let's first take care of one exceptions, which is if node doesn't exist, which is also our base condition, return 0. So left side is equals to 0 if not node.left, else we call this recursive function at its left side, since its left side exists, and use the current value because we need to get the same length, to get the path has the same value. So doing this, we successfully transfer the value to do the check, which gives us the right path. So we do the same to the right side. Okay, after we get this, what's next is we have to update our result, because we need to get the maximum number. We update the result with left side plus right side. So next, what we need to do is to check if the node value is equals to the value we're checking. So if it is the same, what we will do is we will return the value immediately, because that is the path, that is the right path with the same value. So that length, which is a part of the, at least the part of the path length, so we return it in the process. We return the maximum of left and the right side. So next thing left is we return 0 if none of these exist. If the node dot value is not equals to value, which means the path we are seeking is broken, which is why we return 0. Now outside the recursive function, we will call this recursive function one time. Why we don't need to attribute its value to some variable? Because this process already gives us, stores the value we need in the process. That is why we don't need to create a variable to store the value it returns. Root none. At last, all we have to do is return the value we need. Let's check if it's correct. Yes.